So, one thing, so one is like I'm going to deploy this module. So I think I forgot last time to like publish the reading on how to like writing the message and finding cold people to like reach out to. Um, so I deployed them, and just like to remember, like I really love this person's advice. She said, so many people lament that they hate cold emailing, how fake it feels, and so her response is, why are you being fake? Like, just email the people. There are tons of people doing really cool stuff out there. Email those people, or like reach out to those people that you're genuinely interested in, right? And then she talks about, like, this is very impressive. She was on the job market for like 10 weeks, and these are the people that she spoke to. Um, and she spoke to me too because of a friend. We had a mutual friend, someone I knew from high school. So this is just something that she was actively doing, which was finding people that she was genuinely kind of like a little. One good advice is find someone who you're almost like a little jealous of their job. That's a great signal that you're interested, and try to think of like, why are you interested, and reach out and be genuine about why you want to talk to them. So again, I say like step one is just your interests, and then like connectors, right? So it's not, the odds are obviously in your favor if you're more interested and you're able to show that interest in a message. But then even if you get that right, some people are going to respond, some people won't. Some people are just think of themselves more as connectors than others, and they have their practice in networking, and they've seen the value of networking, and therefore they're more willing to talk to you. People that are like that sometimes are actually pretty high up, like CEOs. For instance, when we do networking for the externships, lots of times it's the CEOs of the startups that we'll reach out to, and they'll be much more willing to respond than, say, like a senior engineer will be. Um, you should still reach out to both, or reach out. That's not to say don't reach out to one, but it's also to say like don't be afraid to reach out to someone senior. I gave this example of like he was the head of the Manhattan GMAT. If I just reached out to someone lower in the totem pole, they would have told me I wasn't qualified. But Andrew was like the president. He could do what he wanted, and that was fine for him. Same thing for probably like the first startup job I got to. I made a connection with the CEO. The engineering team did not actually. This is a better example. The engineering team did not want to hire me, and they advised him not to hire me. And the CEO was like, "I don't care. We're hiring Jeff." The engineering team was right, but I was hired anyway. The other thing is to lean on your network, right? So I talked about like the alumni network. This is just an example. Like, these are all the emails I sent after I graduated from law school, and you can see the results, right? So not everybody responded to me. I got a couple like, this wasn't the valid email, but I counted them up. I sent 14 emails. 5 of the people got back to me, and all those 5 led to a phone call. And what's valuable is, even if they don't lead to, lots of times they're not going to lead to a job. Almost none of them will, but they can lead you deeper into a person's network. Meaning, as long as you have the skills that, or the interests that you've identified that you're interested in, they say they know about tech or data engineering and have a network that knows that stuff, they can lead you to the specific people that now are just like, say, finance and data engineering, or cloud and data engineering. The other thing, right, the way that I got in touch with Allison, the person who wrote that blog post, was she asked my friend for an introduction, right? So for you, if you find someone you want to talk to, a good way is see if there's a mutual a mutual connection on LinkedIn, and just ask that. I think I've showed you this, right? I told you that this is something I just got like a week ago. And I didn't even, this person, like, I don't know very well, but I would have made the introduction if I could have, and if I knew this person, Nick. But even like the guy asking me just was a pretty loose connection. And then, right, like, I really recommend this. Like, the more I think about this, reaching out to, like, maybe not someone who has thousands of people that maybe not people that are like very, very famous, but you can experiment with it. People that put out like a YouTube talk, they're people that, one, are doing something like that lots of times because they want to grow their network and like increase their presence. So that's their whole point, is to make connections with other engineers. And then two, because they might already have an existing network, so that you can tap into. So again, this can be really useful. Just like if you, especially if it's something kind of niche that really speaks to you, then following up by just reaching out to the author, just saying, "Hey, I loved your talk. Thanks so much." That's it, and then they'll generally follow up, say thank you, and then from there you can do the second kind of message. All right. So that's the first thing. When you ultimately, and this applies for like an interview you go on, or say you're about to meet someone through like that you think could be really interesting, and have a conversation with them. Just make sure you do some background research. I'd say, like, this way you can have some interesting things to talk about, right? So you can read about like the job description. If it's a job, you can go on their website. Like, what does this company do? Sometimes it's not clear in the job description. Go on their website, see what aligns with you. Try to think of, how does the data engineering team really help solve the company's problem? Like, what are they working on now? Like, that's a really good thing. If you can kind of get a sense of, what do I think the data is like critical for the business right now, and how are the data engineers helping? And then now you have something that, one, like, this is on the person's mind, and if you can help them, that's great. And how do you find that? One is the website. You can look at any news articles maybe about the company. You can go on their LinkedIn of the company and start looking to, clicking through people and seeing what do they do, right? So now you can see this is what I'm doing for this one company. Click through four of them. Most of them are blank, but then finally I got to somebody, and it's like, this is the skills they're using. So even if even I couldn't find this information from the job description, I could find it just with a little bit of research, right? And then this is great. Like, this is even better. Is, say you want to work at a company, look to see like the related blog that they might have. And the data engineers oftentimes are going to could be writing articles about it. So this is a great way, like, if you talk to the person, you kind of know exactly what they're interested in and what they've been thinking about, and you can do some research beforehand so that you can talk intelligently about it, right? And then you can also, of course, go on the GitHub, see things like that. Like, that's indicators of interest. Like, that's showing that you're interested. So there's just like ways to do that, and people will just be impressed that you're kind of like scrappy enough to figure that stuff out, right? So much of engineering is doing the research and figuring it out with minimal information, and they'll be just impressed that you have those skills, to begin with. All right, so I think that's that part. The LinkedIn prep, resume prep, we can leave that for now. One thing, I think this might speak to you. This guy, Vinicius Vacanti, he co-founded Yipit. He's a pretty impressive guy. He's like, he left finance before it was cool. He left finance to start a startup back in like 2009. And was really one of like the very kind of like early members of like the New York tech community when it was just founding in the, you can see when he did this, 2010. So I think, I read this back probably like 10 years ago, but it still just speaks to me, and I kind of hear echoes of what he says in a lot, and kind of I feel the way you all are feeling. He goes, I remember walking into my first New York Tech meetup almost 2 years ago. This is only 2 years after he kind of like, at that point he like kind of made a name for himself. I looked around and didn't know anyone in the 120 person crowd. After watching the demos, I saved 2 seats away from the closest attendee. It's pretty funny. I approached someone to introduce myself. They didn't seem interested in talking to me and walked away a few minutes later. After standing around for a few more minutes acting like I was looking for someone, I just walked out. Ouch. All right, so like I kind of get that that's kind of the fear, I guess, of going to these meetups. But one thing he talks about, he gives some good advice, which is like things that did work out for him. So we reached out to existing friends. He did these cold emails, right, to people in the things. And then this, I think, might speak to you, is like he went to smaller meetups, right? Like, just you don't have to go to the biggest meetup, I don't. That might be worse. Lots of times it is. You're gonna have to kind of see which ones speak to you. Like, when I was a lawyer going to meetups, a lot of the ones would be like 12 people. But as long as they're interested in the same things I were, or maybe some of them you're just like coding. Uh, I did like hacker hours. Like just going to the same meetup as a regular, you can those the people even organizing the meetups will get to know you, especially if it's only a dozen people, and they'll like be happy that you were there and will introduce you to people. Like that happened to me. Um, and then the other thing he does, which I wanted to include this advice. Say you meet someone, you think like, okay, this guy is great. I don't exactly know how to like maintain a relationship with that person. One thing you can do is think of a way to help them. It doesn't have to be huge. It could be like books or communities that you know about, that you learned about, that you can share with them. It could be things on their website, like that you just see, like, could be. It's a little weird. That's what this guy did. What Vinicius did was he met someone really kind of known in the New York Tech meetup, and he made a bunch of recommendations, like errors he saw on his website, or just points of feedback, and that was his way of developing the relationship. For me, oftentimes, what I'll do is I'll send them some resources that I think they might be interested in, uh, and again, like, because if you're finding like that niche area that you're particularly interested in, and then you meet someone in that same niche, and at that point you already have done something. It could be your project. That's another way. Follow up with that. Or you've just done some research and you can then recommend them some books. They'll love that. Like, they will really value that. And I do that all the time. uh, and it shows that you kind of know something about them. You understand their interests and are like that peer. So those are all good ways, I think, to start building a relationship. And the other thing he says in here is, you meet these people, like about half of them go nowhere. But then here he goes. Out of 5 meetings, one will go nowhere, 3 will be good, and 1 will be amazing. That's about right. It's something like that. Maybe it's not quite those numbers. Maybe it's 1 out of 10 will be amazing. But you'll be surprised, like, when it really hits, they can like introduce you to like 4 different people that are valuable. All right. So those parts, and then the other thing I'll put in here, we can go get through this later, is like prepping your LinkedIn and prepping your resume. One thing I did for you though, and I'll help you all with your resume, is I have a link to a sample resume for you, so you can see, right, like, you fill in your name, obviously all this stuff. Here's the technical skills. Here's, our school, any previous things and relevant coursework. Fill in, your internship. Here's something about, how to indicate about Jigsaw Labs, right? So you can start to see that. One quick piece of advice for resume stuff. I don't love it when people, like, lots of times the biggest thing I'll see in resumes is something that's like, I did ETL involving, like AWS Cloud and Docker and, Snowflake or something like that, right? They'll list all the technical skills, but they won't indicate to me how they were applied. The problem with that is so much of the complication and so much of the work that you all did was in understanding a problem and a domain, like a real world that's very, very complicated, and then having to model that in engineering. Like, that's the challenge of an engineer. So, and that's all lost if you don't include that domain context. So what I like to do generally is say, hey, I worked for this startup. I was a data engineer intern for a company that did X. This was the problem the company's solving. Here's what I did, and it should lead back to kind of that startup, right? So I worked for a startup. They they needed to, like, collect like a bunch of different resources on kind of like social support systems in the state of Washington. Our task was to collect this one group of resources that weren't yet there. To do that, so again, we haven't mentioned any technical skills yet. To do that, now comes the technical skills. right? And now I can understand, like, one, that what you did was important. Two, you understand kind of how your work relates to the broader organization's goals, right? And also, I am going to relate that to all the complications that I face working on a similar problem, right? Like, I get that this is not a simple task of just working with Snowflake a little bit and a few queries, but, involved a bunch of stuff. So this is what I recommend doing. Like, give them some context. And by the way, this follows like our pyramid principle information, right? Go broad, then go narrow. And then the last thing, just like an FYI, if you go to, if you look at the Slack channel, our data engineering, I'll reshare Slack. I added here at the top. Oh, not so pretty. Sorry, gang. This is really what you should do. It's these ones. This is the list. All right. So these are a list of a number of job boards that I like. So this one has a bunch of kind of not-for-profit types of or social enterprise jobs, but a lot of them can be entry level. This engineer jobs, past experience, I found that very valuable. Python jobs, right? This I've just recently found this data internships, but it look like both internships and entry level positions. Tech jobs for good, idealist, outer joint, like these are all pretty good things. Progressive data jobs. For these, what you want to do, let me show you, kind of just quickly run through the LinkedIn. So what I generally do when I'm searching for jobs, I'll type in like two different things, right? I'll type in like data, for the search part, because that will cover data engineer, data analytics, data science. But if I want to do like a quick search overall, I'll just type in data in general. Sorry, I have gone out here. And you can put your city, but you could also put like remote. Now, the reason why, you're free to do LinkedIn, obviously, searches. People have had success with that. The reason why I haven't done it, haven't included in that list is, one, I expect about it. Two is a lot of them will get flooded with applicants. So what you want to do generally, there's a couple of things. One, you can look at, what I generally do is do the date posted and do something like the past 24 hours or the past week. And that way I'll get jobs that don't have a ton of applicants. Once it hits over like 50, I would say like you kind of have to also accompany a note. You should be doing that anyway, but probably by 100, right? Like it's a hard, it's not so easy. But if you're early on, like top before it hits to like 50 or so, then it's pretty good. You can get there. Again, what I would do is you can apply to it right away and then take your time, do some research and write a follow-up message. The follow-up message can come like an hour later or a day, probably not a day later, but an hour or two later. That's okay. But in the beginning, like speed does matter a bit. Actually, it matters a lot, to be honest, for just sending in the application. So try to send in the application. Those last times are pretty standard. There's not a lot of thought involved, especially with LinkedIn. But you don't want to just write again that generic spammy message. That should involve some thought. Okay. So what will I do? I'll search for also I'll do experience level, and I'll do internship, entry level, and associate. Right. You could even do mid. I'd say like anything from 0 to about like 4 years of experience. If you've never worked in a tech job before, you're eligible for. We've had people get jobs that were asking for 5 years of experience. That's a bit of a stretch, but it's happened maybe for like 10% of our students that haven't had a previous tech job. But generally, like 3 years and 3 years, I'd say, is within reach, and then 0 to 2 obviously is like your sweet spot. it'd be very rare to find jobs listed for 0 years of experience, but like 1 to 2 is perfectly fine for you to apply to. Right, and then you do like the show, and then you can go from there, right? And you kind of know what positions, right, are pretty good for you. All right. Questions about this stuff?
So you said with the follow up message like an hour later, is that something you add to the existing application, or you just kind of send an email
You can
separately?
send you can send a message separately saying, "Hey, I wanted to reach out. I'm really excited. I saw this position, thought I might be a good fit, and then blah blah." And then you can say like at the end, like I already sent my application. Please let me know, if you're willing to follow up or if you have any questions, something like that. If you have some time to talk, I'd love to talk with you. Right. So, yeah, follow up, but also send. One thing they'll say is send they'll want you to do both. The other thing just to note is like jobs jobs in your area, like geographic area, are going to be easier for you to get than even if the job is remote. You'll have a little bit of a leg up if you're in that area. So it's look for do best try to you should be open to places in person. Most places are hybrid. So look for places in your area, but then also obviously you can apply for remote jobs. It's just going to be more competitive. All right. The other thing to note, I know I keep saying that, but one thing is right. I'm listing jobs in the jobs channel that I see. You want to apply to the same thing. Like I'll try to be good about including the Slack channel that I view them from. Most of them are from Slack, but you basically want to message that person that day. If you see it here, message them that day. Tell them, make sure when you message before you message them, you read the job and you're not sending them spam. That's not going to help. It especially won't help if 10 people from our school all send the similar messages. Like all send a spammy kind of message. So instead just talk about why you're genuinely interested. But anyway, I'll include these. And then the other thing is just to walk through a couple of like my favorite channels. So in DBT, right, you want to go to DBT, manage, browse channels, right, and then here's where you can start to search for general search for jobs and add that channel. You can also, one thing I also do a lot of times is when I go to browse channels, I'll look for sort by most members just to see if there's like anything else I really should be joining. All right. One thing you'll notice, for example, in the DBT Slack, is they have advice for mock interviews. Sometimes there will be like hiring managers where really what they're saying is like, is this a good interview question to ask candidates or things like that. Right here's one I heard today. Blah blah. And then people will give their answers that are oftentimes engineers. So this is a nice thing oftentimes they're kind of like these soft skills questions. So this is a good thing to have. Look, this guy even has office hours. Office hours bi-weekly. I forgot about that. Tuesdays, 4 to 5 p.m. It's not bad. Like, I think that might be a good use of our time. And then here's the MLOps community. These two are my favorite ones. So you can see like learning resources is good. They have different cities that you can, related kind of chats about. Career advice, right, is pretty good. Again, here they had kind of a machine learning engineering interview question. So these are just good things to browse and kind of like hang out. And then, of course, they have a jobs channel. The jobs one in MLOps is in most cases going to be too senior for this graduates of this course, but you can take a look, and if it really speaks to you, message the person. And then again, like, if you're interested in MLOps, obviously this is the place for it. This one's also quite good. Locally optimistic. This is more like analytics engineering / data engineering roles. This also has a last times a lot of pretty good jobs. So these three are like my core ones. Okay. So yeah, so you can add these positions to your tracker. So basically, if you go to here and then go back to data engineering and click on application tracker, right? Then what I would do is in applications, you can see I already did this. I just copied and pasted them here. And now when you're kind of applying for jobs, you can look at them. You have it right here to tell you kind of, and you can rearrange this list, to start using the ones that are more relevant towards you, and add more, if etc. And then keep track, and we can start to see where you get stuck, and what, and like what's being successful and what's not for you. Okay. Trying to think if there's anything else I added here. Yeah, the last thing I did was I added this to if you have these conversations. One thing that was recommended to me by a career coach was, hey, because I'm trying to learn, when you finish, say because I'm trying to learn more about X, Y, and Z, right? Like say this person was really valuable to you. Are there any other individuals who you think it would be good for me to speak to? And they may just say oh, I don't know, but I'll let you know, if any come to mind. Or maybe they will have one or two. And that's a great way to, kind of go deeper in your particular niche. All right. Cool. So those are those readings. And so you can, maybe take 15 minutes, look at them. And then what is next to do is go through this buy and sell a stock problem. Just try to solve it again, right? You're going to see variations of this problem in LeetCode. And then from there, we can probably move on. Let's say we'll try to move on to data structures material from there. I do want to get to this, where we talk about how lists work under the hood, how dictionaries work under the hood, and then do some related LeetCode problems. All right, so for right now, it's basically 15-20 minutes. Look at these 3-4 lessons, and then let's say do 15 minutes on that, and then the buy and sell stock. Maybe spend half an hour on the buy and sell a stock. Remember, even if you can solve it one way, try to find a second solution. Okay, and then we can go through it and move on to algorithm stuff. Cool. So we'll come back in 45 minutes. Just to kind of re-explain it, right? We need to find the maximum profit. One thing to do is, you can give yourself different kind of examples, right? So here I'm giving myself, right, a new example. Can I make this? I just want to clear my screen. Okay, so here I'm giving myself a new example. So we have 7, 3, 8, 1, 2, 4. Now, if I was what's the, what is the maximum profit here? The answer, right, it seems is 5, 3 to 8. There's a couple things to note, right? So 3 to 8. If you're looking at kind of how your brain is doing this, or maybe your brain is doing different things, but one thing I think I'm doing is I'm kind of breaking this list up into different partitions. My brain is kind of going 7 is one partition, and then I'll put a star, I guess, and then 3, 8 is another partition, right? That's another group. And then kind of 1, 2, 4, I guess, is another partition. So it's kind of basically what I think we're kind of eating away. We're kind of like the caterpillar, eating until we get to a new minimum. We're 7, how good can I do? Like, can I make more profit? Can I make more profit? Nope, because the next thing is a number less than. Now I basically reset, once I find a new minimum, it seems like. So every time I find a new minimum, I kind of am like, okay, now how good can I do? Find a new minimum, right? Now how good can I do? So from this stretch, I can make a profit of 5. And from this stretch, I can make a profit of 3, it seems like, right? So one thing to do is like, kind of keep, reset with each minimum, with each new minimum, and then calculate, profit, successive profit for each min. So to do this, like to calculate, to go through each of these minimums, we can just loop through the list and we'll get there. One thing to note, right, is I gave myself an example where the absolute minimum does not work, right? You cannot just find the minimum and then say, oh, well, that has to be involved in the profit, right? Because we gave ourselves an example where that's not the case. If you did not pick up on that, like initially in an interview, that probably would be fine, because what they'll do is they'll give you an example. Like they'll give you an example that forces you to, go further. Okay? Like they'll give you this kind of example. But it's even better, of course, if you can kind of think through it, think of anything that could go wrong, and then give yourself the example, and then say, okay, can I solve this? So, what we could do. Any questions before I move on with this? So what we could do is like we basically want to find the minimum, find like a current minimum, and then each time we find a current minimum, we could calculate a profit. So one thing we could do is just set the current minimum equal to nums, like the first number, or you could do like negative infinity. We just need some sort of initial number, right? And then we can kind of I'm gonna do it down here. For number in numbers, we want to see kind of like current min. So we'll say if the number is less than the current min, then the current min equals the number. And you might just start here, I guess, and you can maybe like print out the current min, So basically I'm just going to check my work and make sure that I am calculating. Like I should see basically a 3, I think, and then like a 1. Those are the 2 ones. And I broke it already. Nums is not defined. That's here. All right, so we can go through the numbers. We see, okay, we did the reset here. And then where is my 1 not showing up? If the number 1 is less than the current min. Oh, because I need to put the print statement below. Right, so we start off with 7. We hit the if statement, but we only hit the if statement when we hit 3. Right? Then we do a reset, and we also do a reset at 1. And then the other thing we can do is, now that we're keeping track of the current minimum with each loop, the other thing we can do is like keep track of the profit. So we start with 7. We see, is there any profit? And one thing I did was I said like, we could do something like it's only profitable if the number we're on is greater than the current minimum. So we could do something like this. Just calculate all the profits. We will store it. So store a bunch of profits. I'll say only if it actually is profitable. Say profit equals the number, the number minus the current min. All right, so this is like, say the current min is 3, the number minus the current min will be 5. So profit is just going to be the number minus the current min. And then we'll say if the profit is like positive, this is my other solution, is greater than 0, then we can profits dot append a profit. All right, so basically I'm just going to store all the profits, everything greater than 0. So, I'm only going to store it. I'm not going to store any negative numbers. That probably doesn't make sense. Yeah, let's take a look. So you can see, let's just make sure this was right. Right, so here's my first profit. Right, is this stretch right here. And I just, I have my current minimum that updates, and then I'm just subtracting at each step the existing number minus the current minimum. So if it's 7 minus 7 is not greater than 0, right? So we don't store it. Here, 8 minus 3 is greater than 0, we store it. And then in this case, we do 1, 2, and 4. We have a profit, I guess, of 1 here. And then we have a profit of 3 here. Okay? And then finally, we can just do max. What's the max overall? And the answer, if we take out the print statement, is 5. Yeah, that works. That's fine. Maybe it's not as elegant as like my first approach, but you can see, like, we can always improve upon this from there. But yeah, this was like another idea I had. Was okay, let's just kind of notice what's going on. We're resetting the minimum, and let's just calculate all the profits. And then we'll say it's a profit if it's greater than 0. You probably could even, just even calculate all the numbers and still take the max. I probably don't even need this. I wonder if this would work. This might be even simpler, right? So I'm just always going to calculate the profit. So this will be 0. And then here we'll reset the minimum, right? And we'll be, I don't know that this will work. Let's see. Let's take a look. Yeah, so we have 0 here because it's profit minus the current number. And then here, let's say we calculate this down below. It's probably less confusing. So here we say the profit is the current number, and now when we get to 3, we reset the current minimum, but there's obviously no profit if we buy or sell at that point. And then here, we still have our current. We move on to 8, but the current minimum is still 3, so we make $5. And then now we reset the minimum, and so we don't make any money. We bought basically there, but now we finally make $1 here. And now we make $3 here, and then we can just take the max of this. So you can calculate the profit basically at every step and reset the purchase. So, I have a reading on this. If it takes more time, if you want to kind of digest this a little bit more, feel free to go through it. Any questions about this type of thing, right? The key thing we're doing is basically recalculating the profit and then just keeping track of the current minimum and noticing that kind of like we reset, right? It's our profit that we can make is just the current minimum or the current number minus the current minimum.
Would this solution be n squared?
No.
To return the max of the profits afterwards? Right?
No. This is actually 2. So that's a great question.
Oh, it's 2n. Okay, because it's outside the formula.
Exactly right. Right? So just to go through that for everyone, this thing is n, right? Because we're going through every number on the list. And this thing, the max calculation, what must this be doing under the hood, is again going through every element in the list to find the max, right? But these two procedures, it's this procedure plus this procedure, which gives us 2n, and we know that 2n just reduces down to n, right? So this is okay as well. Even if you get an n squared solution, that's fine. And then you can just tell the interviewer, ideally we'd like to, optimize this, and you'll see if they kind of lead you to ask you to do that, or if they're okay with this. All right.
This solution takes extra memory space, right?
Yeah, it does. Right, it does probably take. Well, one, we are, we're creating this new list. Generally, people will care about like speed complexity more than size complexity. I mean, especially in the real world, they will too. But but yeah, they could ask you, okay, now do this without creating a new list, right? But I would say that like let the interviewer like get the answer first, and even getting the answer wrong is kind of okay as long as you're making progress with the logic, right? It's like, okay, we'll do it this way incorrectly, but now give yourself another example that will force you to, right, debug it. It's almost like a test-driven approach, right? Okay, we got this far, now write another test. Give yourself another example to pass that. But the point is to be iterative. All right. Yeah, like ideally, I like the earlier approach that's in the solution a little bit better. Um, but either, this is fine. All right. Let's move on to like data structures. We will be coming, don't worry, we'll be doing plenty of these types of problems. But yeah, just to move on to data structure. So right, we talk about lists. We all know what lists are from like the pre-work. Right, and the key thing about lists is that lists are ordered. Okay, meaning that things are in a sequence. Okay, and under the hood, lists are ordered as well. Like if you look at how a list works, the way that Python creates a list, or really any language, is when you create a new list, Python will allocate a certain amount of space in memory for that list to exist, to store the contents of that list, just right off the bat, once you press shift return. Okay? So I don't know exactly how much space they allocate, but what you can imagine is, let's say they allocate for 9 elements, and what they'll do is it will be what we call it contiguous, meaning it's that entire, let's say it's like 100 bits of memory, all that space is touching each other, okay? And it's partitioned so that the first element might be at the very beginning of the list, right, is right here, and then maybe we'll give it 8 bits of allocation just for that one element, and then another 8 bits here, then another 8 bits here. We're always giving the same amount of space per element, okay? The benefit that we get from that, right, is that let's say this list exists, maybe I can do a little whiteboard. Let's say we create a new list, okay? And so Python allocates memory address 100. This is just a location on your computer, right? And you store the string, like X there. And let's say there's 8 bits of memory per each element. Now we say, and let's call this my array. If I want to now retrieve array square bracket 2, and let's just put a couple letters in here. Let's say this is Y, and then this is the letter A. Okay. What location in memory, right, is this string A located at? Or a better question to ask is, what location in memory is the element at index 2? Where do I need to go to find out what it is? We should be able to, we can just do the calculation, right? It's 116. How do we know that? Because we're starting at position 100, right? My list or my array, it starts at position 100, and we know we allocate 8 bits per element. So Python doesn't have to go, how many steps are involved? Just one step to find an element at a specific index. Okay, that's what's very nice about kind of lists, is retrieval of data at a specific index takes what's called, right, O of 1, big O of 1, right? It's just one step, if you know the index you want. So when can this particularly become important? Let's say we sort the list, right? As long as I know the list is sorted, A, C, all right, D, and I want to find the smallest letter. well, this only takes one step. If I want to find the largest letter, right, this only takes one step. If I want to find the letter in the middle, right, we just calculate the length of the list, divided by 2. That only takes one step, right? So when you know the specific element, lists are great. In terms of now, retrieval, retrieval at a specific element is big O of 1. Now, in terms of making modifications, right, there are different things we can do. So let's do this. Let's say this is, we'll just do 2 more. Okay, so now let's say we want to pop an element, meaning we'll remove the last element from the list. To do that, all Python will do is change the ending memory address 1 spot earlier. It's not hard at all. That's also big O of 1. So removing an element from the end generally takes just 1 step. Adding an element in most circumstances, also not hard. Let's say we have an extra slot over here that Python allowed for us. We just tack it on. It's just 1 step. Removing an element from the beginning, however, is more costly. All right? Because what will Python do? 1, it will remove this. But remember, we're still starting at address 100. So each one of the successive elements goes down, it gets moved up 1. Right now, this guy's at index 0. So to do that, to move each one of the elements up, costs n. All right? So removing from the end or adding to the end is big O of 1. Removing from the beginning or adding to the beginning is big O of n. All right? Now, in most cases, I should say, adding to the end is big O of 1. The cases where it's not is basically, imagine we create a list, we allocate, 100 bits of memory, or I guess maybe, 56 here. But now there's an image. We put some of the stuff in memory, but then there's also an image or whatever. Here's your email. I don't know. Some sort of information is taking up this space. And now you add another element, and there's no space over here. Okay, right? They're doing something else over here, your computer. What Python needs to do is find space for your growing list. So it's going to have to copy over all the existing elements and then find another place on your computer to both put those elements as well as leave room for more. So pop, or not pop, but appending sometimes, right, can cost big O of n, right? The cost of copying over all the elements into a new list. Does that make sense? But most of the time, just know that adding to the end, removing from the end is big O of 1, but adding to the beginning, removing from the beginning is big O of n. And then retrieval at a specific element is big O of 1. All right? Questions about this? Why is this important? Because when you calculate the cost of your operations, right, it's important for you to know, okay, this is free, right, effectively if it's big O of 1, but not if you're adding to the beginning of a list.
I remember in other languages, you can specify the length of your list or how much memory you want to allocate to a list beforehand. Is there something like that in Python, or
Not
is it
that
just
Wayne or Micah, feel free to jump in, but not that I know of.
Gotcha.
Yeah, I don't think so. What else? Okay. When can lists so lists are very good when we know about retrieving at a specific element. What are lists not great for? Or maybe we can do a little bit better. Let's say that we have a list of names. Or it might be better. Let's say we have a list of books. We're a library, right? And so we have a list of books, and we'll say, we have Tom Sawyer. And even if this is sorted, like Harry Potter, well, let's say that it is sorted, right? To make to make things easier. And then Adventures. I'm trying to think of a book that begins with an A. So that'd be Adventures of Huck Finn. Okay. So we have this sorted list, and now we want to know, does, let's say, some other book that begins with like a C, Cats, that's here. All right. If we want to know, like, does Cats exist in the list, but we don't know the index, what do you have to do? You basically have to take a guess in the middle, right? Generally what you'll do is you'll take a guess in the middle. Like, let's say we know the list of length 4. So say, like, what's the length of books? That's 4. And then what you'll do is you'll choose the middle one. Like, let's say it's this one, Harry Potter. And you'll say, okay, what's at books number 0, 1, 2? And you'll see, okay, it's Harry Potter. And you'll say, okay, that's too high if I'm looking to see Cats. Does Cats exist in this list? So then you'll go to this part right here. And now it could be in the beginning, it could be the first element, or it could be the second element. So let's say you guess wrong, and you do say, okay, let's look at the first one. And now we get back Adventures. So now we know if it exists, we kind of have to go in between. Sorry, why am I doing that? Books. And then we finally go here. This thing's called binary search. This is the phone book method, right? If you like have a phone book and you're trying to find somebody's name or find a listing in the phone book, what do? You like open up the middle of the phone book, see where you are, right? Then you see, am I too high or too low? Divide it in half, right? So we do one partition, divide it in half, then keep dividing until we find the answer. Now this is still kind of costly to do. This costs log n to do. Basically, you just, meaning how many times do I divide until I get to the answer? It's not bad, but dictionaries improve upon this. So lists are good when I know where the element is by the index. They are not very good. Even with a sorted list, they are still not good at, say, finding information. Okay? We can improve upon that. Here's how dictionaries improve upon that. Well, think about, I'll just tell you how it works, and then we can give you an analogy. So the way that dictionaries work is, let's say we have a key of, let's say each title is their own key. So we'll say like Huck Finn. There can be a space, it doesn't matter. They'll put this through what's called like a hashing algorithm, meaning it's just a formula that or really like a function that takes the string or whatever you're passing through as the argument, and based on that string will spit out some numbers. Okay? These hashing algorithms can be pretty complicated, so you don't have to know like really where these numbers are coming from. Just know that Huck Finn's going to spit out this number, and that number is where Huck Finn lives in memory. So